Hello everybody, it's Mr. Morgan. We're going to be talking about 8.4c today, which is using data from a table or graph to determine the rate of change or slope in the y-intercept in mathematical and real-world problems. We're going to be focusing on mainly finding the slope. This is sort of like a tutorial simply on finding the slope, that very first part. There will be other videos where we will incorporate these. Other items in the TEKS, but for now we're just working on that individual skill because I think that we just need to make sure that we're seeing exactly what we need to see. So we will go ahead and get started now. The first thing that I'm going to do is I'm going to show you a general indicator. It's sort of a way for you to check your work as to what we are actually looking at. All right, so sorry for the hard edit there. There was part of the problem revealed that I didn't want you guys to see just yet. So as we notice here with the courtesy of the slope tree, we have things labeled here. Now, if the shape of your line is actually going to be in this direction, we're going to call that slope, or say that slope would actually be positive. If we know that the shape of the line is in this direction, we're going to say that the slope is negative. If you have a completely vertical line, we're going to say that slope is undefined. And then the slope of 0 would happen when we draw that line directly across. We will start off by looking at two different graphs. And again, remember that the skill that we're working on in this particular video is simply the skill of trying to find the slope given 2 points. So I am going to go ahead and go over, it looks to be, to this first graph. Now, I'm specifically looking at this point and this point. Now, if we think about what we already know about scatter plots and negative and positive trends, basically, I'm going to realize based on the slope tree that the slope that should result from this should be a negative slope, in that as the y values increase, so the farther that we get away from the y-axis, so as the x values increase, I apologize if I said that wrong, as the x values increase, your y values will also decrease. So from this line to this line, x is getting larger, and y is getting smaller. Okay, so our resulting slope should come out to be negative. Okay, and I'm going to go ahead and reveal that now on our problem. Okay, so as we see here, I have the points that I'm going to be dealing with. The points that I'm going to be dealing with are 3 and negative 5, 3, negative 5, and 1, negative 2. So what I want at this point is I want to go ahead and start calculating our slope. We know that our slope formula says that this will be y2 minus y1 is over x2 minus x1. I am simply going to plug in the values that I've already determined here. So if you notice, I've already labeled them. I have x1, y1, x2, and y2. This is my first ordered pair, x and y value. My second ordered pair, x and y value. So that's why they're numbered 1 and 2. You just have to be very consistent when you're dealing with them. Okay? So what I'm going to do right now is I'm going to continue to simplify. As I simplify, I'm going to plug in the value. So I have negative 2 minus a negative 5. We'll talk about that in a moment, what that actually simplifies to. I show now x2, which is 1, minus what? 3. So again, you need to make sure that you have labeled them, okay, and that should be very clear at this point for you. So I'm going to go ahead and start to solve. This becomes 2 plus 5, negative 2 plus 5, and negative 2. Now these are just regular integer rules. So again, when I'm subtracting a negative, that becomes a positive. I'm going to keep my negative symbol for that first number. So negative 2 plus 5 is going to be 3 over negative 2. So the entire fraction now becomes negative. That's my slope, negative 3 halves. Okay, so what I want to do now is I want to go ahead and switch back over to my original sheet. I'm going to go ahead and show you another one. Now, at this point, we have 0, 1, and 2, 5. We need to figure out what the slope is. So notice, my slope, or my line, I should say, is actually going in this direction now. It's going to be in a different shape. So if we think back to the slope tree, we're now going to know that that should result in a positive number. If I get anything beyond or besides a positive number, I know that I need to go back to the drawing board. So at this point, I have switched back over to my, okay, I'm expecting a positive number at this point. So what I want to do is I want to go ahead and set up my slope problem again. That's m is equal to y2 minus y1 over x2 minus x1. I've taken the liberty of also labeling everything. I know that I'm going to be dealing with my y's first, so I'm going to go ahead and circle those. Okay, y2 and y1, two different ordered pairs, and I know that what I'm going to be doing. So I have 5 minus 1, x2 is 2, x1 is 0. This becomes 4 over 2, which will then simplify to 2. So I have both a positive slope for this one, which I was expecting based on the shape of that line, and then as before, again, I have a negative slope based on the shape of that line. I was expecting that. Okay. Now, as always, if you have any additional questions, you may watch this video over again just to sort of see if it'll click. If not, ask me in class. If that doesn't work, please come to tutorials on either Thursday or Tuesday of every week. So Tuesday, Thursday, every week. And as always, I will see you tomorrow in class.